This video is looking at binomial distributions. Now, the key to binomial distributions is that the outcomes are discrete. We have n independent trials, and there are only two possible outcomes, either success or failure. And we will look at the probability of success, and that's what we will deal with. So the probability of success is P, and the probability of failure is Q. And because our probabilities add to 1, Q has to be 1 minus P. Now, if you want to use a combination formula, it's here. The good thing is we don't need to, but if you want to look into that more, refer to your textbook. Using our calculator, we will be using the distribution function, and you get to that with second vars. So on the calculator, the vars button is just under the navigation keys. Find the probability of a particular event happening, then that's binom PDF. Okay, so it's when it's equal to the number of events, the probability of the event, and how many times you want that event to happen. To be less than and equal to, we're looking at a cumulative distribution. So that's binom CDF, and again, number of trials, probability, and what x is. If we have the probability x is greater than a certain number, then because our calculator will only go less than and equal to, we have to change it to 1 minus the probability is x is less than equal to x. So just remember, you're always dealing with either equal to or less than and equal to. Okay, on our calculator, if all we enter is our n and our p, we don't enter an x, then we will get the individual probabilities for each thing. So starting with x, so starting with 0, so the probability x is 0, probability x is 1, probability x is 2, etc. So let's look at an example. Here we have the probability of having a boy is 0.52. In a family of 5 children, calculate the probability of having exactly 3 boys, more than 3 boys, and at least 1 boy. Now this is a binomial distribution because having a boy and a girl are discrete events, okay? Also, our P, or the probability of success, is we're looking at the probability of a boy. So our success in this case is going to be boy, and that probability is 0.52. Okay, so therefore our p-value is 0.52, and it says in a family of 5 children, so our n is 5. Okay, now remembering from the previous slide, probably x equals x is binom PDF NPX, and probability of x is less than and equal to x is binom CDF NPX. Okay, so if we want the probability that x equals 3, so the probability of having 3 boys, that's going to be binom PDF. Our number of trials is 5, so 5 children. Our probability is 0.52, and we want 3 boys. So let's go to our calculator. So we want second vars. So we go into distribution, and then we go down until we get binom PDF, which is A. Okay, press enter. Our number of trials is 5, enter. Our p-value is 0.52, enter, and our x value, we want 3 boys, so 3, enter. That will now paste it into our screen, press enter again, and it gives us the probability is 0.3240 approximately. Okay, so that is 0.3240, so therefore approximately 32.40% chance of exactly 3 boys. Okay, moving on, more than 3 boys, the probability x is greater than 3. Okay, now I can't do greater, I can only do less. So that's going to equal 1 minus the probability as x is less than and equal to 3. Now, if you're unsure of that, the reason is probability x is greater than 3. We're looking at 4, 5. Okay? So 1 minus probability x is less than equal to 3. Well, x is less than equal to 3 is going to be 0, 1, 2, 3. So that will leave us with the 4 and 5 because we're going 1 minus. So this then becomes 1 minus binom CDF. It's CDF because it's less than and equal to. Our n is 5. Our probability is 0.52, and we want 3. Okay, so we have 1 minus binom CDF 5.523. So we go to calculator. We go 1 minus second vars to get the distribution. Scroll down, or if you remember it's going to be at B, you could do that. But get down to binom CDF, press enter. Number of trials is 5. Our p-value is 0.52, and it's less than and equal to 3. So that's 3. Enter, enter. And it's 0.2135. So this is equal to 0.2135. And these should all be approximates. So therefore, approximately 21.35% chance of more than 3 boys. Okay, our last one is at least 1 boy. So the probability that x is greater and equal to 1. That's going to equal 1 minus the probability that x equals 0. We want everything but having a boy. So that's going to be 1 minus binom PDF. 5 trials, 0.52 is our probability 0. So go to our calculator. 1 minus second vars. Scroll down. Enter. 5 trials, 0.52, and our value is 0. So 0.9745. Always make sure that this makes sense to you. You know, you would think there'd be a high chance of having at least 1 boy out of 5. So that's why the probability is so high. So therefore, approximately 97.45% chance of at least 1 boy. Moving on, a new drug for hay fever is known to be successful in 40% of cases. 10 hay fever sufferers take part in the testing of the drug. Find the probability that. So important stuff. That the drug is successful is 40%. Okay, and we're looking at 10 hay fever sufferers. So our probability of success in this case, which is what we're looking at, is 0.4. So our P is 0.4 and our N is 10 hay fever sufferers. So the probability that X equals 4 is going to be binom PDF 10 0.44. Now I'm not going to go to the calculator this time. You should know where to find it. So that's 2.2508. Next, no people are cured. Probability that X equals 0. There are no successes. So that's binom PDF 10 trials. Probability is 0.4 and we want it to be 0. And that's 0.0060. And then the probability that at least half have cured. So we want X to be greater and equal to 5 because 5 out of 10 would be half. So that's 1 minus the probability X is less than and equal to 4, which is 1 minus binom CDF 10 0.4 and 4, which is 0.3669. And you have to finish with therefore statements. So the first one would be approximately 25.08% chance that 4 people are cured. Second one, approximately 0.6% chance that no people are cured. and then the last one would be approximately 36.69% chance that at least half occurred. Moving on to the next problem, you should pause the video and have a go at it yourself. Okay, so an enemy's factory has been destroyed, so a barrage of 12 factory-seeking missiles. Sorry, an enemy's factory has to be destroyed, so a barrage of 12 factory-seeking missiles is launched. So you got 12 missiles launched. At least 4 missiles need to hit the factory to destroy it. Assume the probability a missile hits the factory is 0.35%, so that's that the missile hits, and that missiles hitting the factory are independent events, which tells us it's binomial. Find the probability the factory is destroyed completely. So if we write down our information, the probability of a hit is 0.35. So that means our p-value is 0.35. We're looking at 12 missiles, so n is 12, and for destroyed, we need at least 4 to hit. So x has to be greater or equal to 4. So our probability that x is greater and equal to 4 is going to be 1 minus the probability x is less than and equal to 3. So that's 1 minus binom CDF, 12, 0.35 is our probability, and we want 3. So that's going to be 0.6533. So therefore, approximately 65.33% chance that the factory is completely destroyed. Okay, moving on. Again, pause the video, have a go at it yourself. Don't just watch, you have to be learning this. So the question says, in a recent survey, 60% of respondents were found to have OzStar. In a sample of 10 people, find. So our probability of OzStar is going to be 0.6, and we'll let that equal our p-value. So it's binomial because they either have OzStar or they don't, and it's independent because one person having it doesn't affect the other. And we're looking at 10 people, so n is 10. So the probability of exactly 2 people having it, x equals 2, so that's binom PDF out of, out of 10 people, probability 0.6, and we want 2. Go to our calculator, it's 0.0106, so it'll be therefore approximately 1.06% chance that exactly 2 people have OzStar. The next one, probability that less than 4 have OzStar. So the probability that x is less than 4 is going to equal the probability that x is less than and equal to 3. Remember, we need the less than and equal to go to our calculators. So that's going to be my binom CDF 10, 0.63, which is going to be, again, these should be approximates, 0.0548, and we'd finish with, therefore, approximately 5.48% chance that less than 4 people have OzStar. The next one, the probability at least 5 have OzStar. So the probability x is greater than equal to 5 is going to be 1 minus the probability that x is less than and equal to 4. So that's 1 minus binom CDF 10, 0.64, which is approximately 0.8338. So finish with, therefore, approximately 83.38% chance that at least 5 have OzStar. Last one, the probability that more than 7 have it. So the probability that x is more than, so it's not greater and equal to, it's just greater than, more than 7 have it, is going to be 1 minus the probability that x is less than or equal to 7. Okay, the probability that more than 7 have it, so the probability x is greater than 7, so we want 8, 9, and 10, so that's going to be 1 minus the probability that x is less than or equal to 7. So that's equal to 1 minus binom CDF 10 0.67, which is approximately 0.8327, and you'd finish with, therefore, approximately 83.27% chance that more than 7 people have it. Okay, the last slide is just looking at the effect of changing P on the binomial distribution graphs. So you can see in this first set of graphs at the top that I'm only changing P. So N is 8 in all of these, and from left to right, it's our p-value is increasing. So when our p-value was less than 0.5, we have a skewed distribution, and it's positively skewed. Okay, so our tail is in the positive section. That's what that means. So it's skewed to the right. When our probability is 0.5, it's approximately symmetrical. Okay, we also call this a normal distribution curve. And then when p is greater than 0.5, the graph is negatively skewed, or skewed to the left. So our tail is down the negative end. Okay, so that's when I change P. Now let's look at changing N and keeping P the same. So first one, N is 5, then I have N is 15, then I have N is 25. But in all cases, our probability is 0.5. And as you can see, as N increases and the interval between the columns decreases, the graph approximates a smooth hump or a bell-shaped curve. So what I mean by that is in the first one, it's quite steep and big jumps, whereas the jumps get less and less, and then we have a very smooth curve. Okay, so exercise to complete, or exercises to complete. There are 2 exercises from your standard textbook and 1 in Maths Quest. So Maths Quest is on the Google Classroom.